Okay, so here we go. This is 6.5. If you want to follow along, do. If you don't, work quietly, okay? So 27, from the fact that XP is perpendicular to OX, so they're just saying that, I'll just highlight in yellow, XP is right here. Here's OX. They're saying they're perpendicular, so I know there's a right angle there, right? I can actually go ahead and draw it in. They're going to painstakingly break it down in such tiny pieces that that's probably going to be a question here in a minute. From the fact that XP is perpendicular to OX, what kind of triangle is OPX? If it has a right angle in it, what do we call that kind of triangle? And then a right triangle, right? Okay. So sometimes they ask questions and we think, okay, that was hard. Sometimes it's so easy that it seems hard. 28 says, what is the relationship of angle OPX? So they're talking about this angle here, OPX. What's the relation of it to POX? What do we know about those two angles? They're congruent. And the reason we know they're congruent is because if this is 45, if you remember, if you've got a right triangle and this is 45, that the fact that this is taking up 90 of your 180 degrees means you only got 90 degrees to split the other two angles, split between those two angles. So 90 minus 45 is 45. They didn't label that, but we know that's 45 degrees. We can figure it out pretty easily. So the relationship is they're congruent or they're equal. I don't care whether you put equal or congruent. Oh, that's not what the book's looking for, though. I'm glad I wrote this down. So we actually jumped 2 or 3 steps ahead when we answered that question. Do you know what his answer to this was? They're complementary. Would I think, oh, you did it wrong if you put congruent there? No, you just jumped more steps than he meant for you to, but how are you supposed to know? He put that they're complementary. And we know they're complementary because, 180 minus this right angle here would leave me 90 degrees. Two things that add up to 90 degrees are complementary. So he actually meant for you to put that there, but who knew? Not me. That's why you have the answer key. What is the measure of OPX?
Is that right?
That was, yeah, it did. We figured that out a while ago. See how you can easily do 2 or 3 steps just by thinking about what's in front of you? That's 45 degrees. We figured that out, way long time ago. That's why I get kind of annoyed at this. I wish when he divides them up into such little pieces, sometimes I'm like, how was I supposed to know that's what you wanted there? Why is XP equal to OX? We know these angles are congruent, right? Okay, so he's asking why is why are those two yellow lines congruent? Basically, that I traced over. Well, we know the angles are 45 degrees, right? But the reason those two lines are congruent goes back to, you remember we had that theorem that said if you've got two congruent angles, then the sides opposite them in a triangle are congruent. Remember there was that was a while back now, right? That's one of the reasons why I think the proof book is good. You can always flip back through it if you're like, I have no clue what he might be getting at, or you could peek at the answer key. I know you can do that too. But if these two angles are congruent, then this side over here would be congruent to this side over here, because in any triangle, if you've got equal angles, the sides opposite the equal angles are congruent. So if two angles congruent, sides opposite them are congruent. So again, you can abbreviate. The angles are congruent. Maybe you write something like that just to abbreviate it a little bit. Okay, so I drew the figure already. This is looking at 31 through 37, and it says in the figure at the right, the angle of elevation of the North Pole at P is angle 1. So this angle 1 is, if you look, I couldn't fit it on the diagram, but there's two lines pointing straight up, and they're just showing that they're both pointing true north. If two lines are pointing true north, wouldn't they then be parallel? So we kind of see, if we got two lines pointing true north, they're going to be parallel. So we're going to have some parallel line relationships here.
Can I go get my computer?
Sure. Okay. So we got that going on. It says the latitude of P is angle 2. Okay. And then OA is perpendicular to PC. Well, I kind of already said that. I'm sorry. OA is parallel to PC. That's these two things that are true north. So here's our parallel lines in yellow, okay? Probably that's not the best color. Let me pick something that will stand out a little bit. But here's our two parallel lines here, if it will draw. And it is not drawing. Please don't freeze on me. Okay. So two blue parallel lines. There are two right angles. One of them's right there, and the other one I colored in red because it was kind of hard to tell, and now it looks like a red dot, and it's unrecognizable. But that red dot is supposed to be a box, but again, that's what you get when you get this kind of accuracy here. Explain why angle 1 equal angle 2 by answering each of the following questions. So he's going to try to lead you through angle 1 is equal to angle 2, and he's going to give you a little step at a time so you don't actually have to figure it out. You're just following his logic and saying, well, that's true because blah, blah, blah. So why is angle 1 equal to angle 4? Anybody see what that one would be? I don't want to write too much on the video because then it'll just get all trashed and you won't be able to read it. Do you see that these, if you look at the blue lines, that black line right there could be a transversal, couldn't it? So those would be alternate interior angles. So wouldn't they be congruent because of alternate interior angles? We have parallel lines. So the reason that's true is that with the parallel lines, and I'm just going to put with parallel lines, alternate interior angles are congruent. Angle 1 and 4 are alternate interior angles, so they're congruent. So I've kind of written the question here. You don't have to write the question. I just did it so I could kind of not be going back and forth. What relation does angle 4 have to angle 3? Maybe you come off to the side if you need to and draw it. That red blob, remember I told you that was a right angle? And here's 3, and here's 4. What's the relationship between those two? They're complementary. You got a 90-degree angle. 180 minus 90 leaves you 90 to split between the other two. They are complementary. So that's what your number 32, that's what he's getting at there. And why? I think in this section, I'm assuming, yeah, in corollary 2, if you look on page 237, corollary 2, I'm just going to write that here so you remember it was in this section. The two acute angles of a right triangle are complementary. So from now on, when I got a right triangle and I got two little angles, I'm not going to go 180 minus 90 is 90. That leaves us 90 to split between the two. There's a corollary that says all that. The corollary says the two acute angles in a right triangle are complementary. So you see how once we kind of have proved something, and that's one of the reasons he has you prove in some of these corollaries in some of these lessons, you get a new thing that you can use so you don't have to go re-explain it every time you run across it. So that was that corollary 2 on page 237. What relation does angle 2 have to angle 3? Anybody see? They told us that OP, that kind of thing that looks like it's going across, not OP, that diameter of that circle there that gets going straight across, they told us that that line was perpendicular to OA or ON, which is this blue line right here. If those are perpendicular, then it means there's a right angle here also. So if there's a right angle, what's the relationship between angles 2 and 3? What could we say about those? They're complementary also. So that's what he's getting at there. They're complementary. That has to do with the fact that he told us those little pieces of that little line segment was perpendicular to that other one. So what relationship does angle 4 have to angle 2? Here, let me show you what you got to do. Let me use blue. Here, 4 and 3 are complementary, right? And then they said 2 and 3 are complementary. If two angles are complementary to the same angle, they must be equal. They'll be equal. They're still, both of them are complementary to 3. So whatever 3 is, if they're both complementary to 3, that means those other two must be equal. There's probably a theorem for that. Let's look and see. If it's kind of a play on that corollary 1 on page 237. If two angles of one triangle are equal to two angles of another triangle, the third angles are equal. It's a little bit of a play on that. He says here, if you look at what he wrote in the book, he'll put complementary, actually it's corollary 1 is what I came up with. I was looking at this before. He's using that corollary 1. Angles complementary to the same angle are equal to each other. So what we could write out here, and let me write it in red just so it sticks out. We now know that angle 4 is equal to angle 2. Let me see if I can't mark that with, so 4 and 2 are equal. I'm just going to mark those because apparently we're going to build off that, or he wouldn't have put that in here. Actually, 35 is that angle 4 equal angle 2, and the y part of 36 is this two angles complementary to the same angle or equal to each other. I've noticed sometimes he has us proven the corollaries. I think in 6.4 especially there were a lot of those that we prove. 37, why is angle 1 equal to angle 2? Backtrack a little bit. Look up here. Angle 1 was equal to angle 4. Angle 4 is equal to angle 2. So angle 1 is equal to angle 2. There's a lot of different things you could say there. You could say substitution. You could say what? Transitive property. All of that would be okay. I'm just going to put substitution. Again, that's one thing about this book you kind of got to realize. If he's asked you a question before and you've got it listed, do you see how because I wrote it down, it was easy for me to go back and find it? If I just write the answers on my paper, I wouldn't have seen that so much. I would actually have to go, sometimes you actually have to look at the original questions, and if you do, you kind of see 31, angle 1 equal angle 4. 37, angle 1 equal angle 2. Somewhere in there, did we have angle 4 equal angle 2? Yeah, that was on step 35. So a lot of times, if you just got the answers on your paper, you might need to glance over at the questions to kind of pick up his logic. It's just, that's one of the reasons I like writing it both down. It ends up that I have everything up here that I need between the answers and the questions. So that's where he went with that. And again, I wouldn't have thought to do it that way, but he's showing us that even if we don't think of it ourselves, at least we could follow the logic and give the reasons that it was true.